The single greatest advantage of ladder line open wire feed line in amateur radio is its extremely low loss even when operating with a very high standing wave ratio. While coaxial cable like RG58 or RG213 is convenient, its internal losses compound rapidly when SWR rises. Ladder line, by contrast, is mostly air insulated, meaning it can operate efficiently even when highly mismatched. Here is a breakdown of why many hams choose ladder line, particularly for HF operations. Multi-band antenna flexibility. Because ladder line ignores the high SWR that destroys efficiency in coax, you can use a single non-resonant antenna across multiple bands. Multi-band antenna flexibility. The classic example is the doublet antenna. If you put a 130-foot wire antenna and feed it with ladder line, you can use a wide range antenna tuner in your shack to force a match on 80 meter, 40 meter, 20 meter, 15 meter and 10 meter. If you tried feeding that same non-resonant wire with coax, the SWR induced losses would turn most of your transmit power into heat inside the cable before it ever reached the antenna. Negligible attenuation. Even in a perfectly matched 1:1 SWR system, ladder line has significantly less inherent attenuation than coaxial cable. At HF frequencies 3 to 30 MHz, the matched loss of true open wire line is so close to zero that it is often entirely ignored in station calculations. Here is an interesting visualization comparing the feed line loss between RG213 and ladder line. You can see that at the basic level, that is SWR1 and frequency 14 MHz and length of the feed line 30 meter, you have 0.24 dB loss for RG213, while it is only 0.04 dB for ladder line. It's quite small. Suppose you increase the SWR. As SWR increases, you can see that the loss in RG213 is increasing disproportionately, say at 2.6. It is this much. When you go higher up with SWR, you can see that the curve diverges very much, so that the loss is disproportionately much higher for RG213. There is the advantage of ladder line. We'll come back and then change with frequency also. For a lower frequency it is less. When you increase it, the divergence is much more. When you reach 30 MHz, the divergence is very much. And then with the length also, when the length is 1 meter, it's almost similar with SWR normal, that is 1:1. And when it increases, when the length increases, naturally the loss is also going to increase. It has gone beyond the graph. So for 100 meter it is tremendous. And if you add with the SWR also, you see that's going to be much more. This is the graph becoming smaller only. It's actually the loss is quite high, 2.82 decibels, while this is only 0.66 decibel with a high SWR, long length, and for higher frequency 30 MHz, this will be 3.92 dB and 0.99 dB. So that's a very interesting visual, of course AI generated. High power handling. Because the conductors in ladder line are separated by inches of air or steady dielectric plastic in the case of window line, it is extremely resistant to voltage arcing. Even cheap homebrewed ladder line, like the one which I have, can easily handle the maximum US legal limit of 1500 watts without the risk of melting or breaking down, which can happen with smaller gauge coax under high SWR. Cost and homebrew potential. Ladder line is incredibly easy to build yourself. You can create true open wire feed line using standard copper wire and non-conductive spreaders like PVC pipes, pieces of drip irrigation pipe, that's what I am using, zip ties, or even 3D printed plastic. The trade-offs. While the RF performance of ladder line is vastly superior to coax, it comes with physical installation constraints. Metal proximity. Ladder line radiates a balanced field. If it runs parallel to a metal mast gutter or house wiring, the field is disrupted, causing the line to become unbalanced and radiate RF into the shack. It must be twisted gently in the wind and kept away from large metal objects. Weather sensitivity. While true open wire line is mostly immune, the plastic in 450 ohm window line gets wet during rain or ice storms. Even with the open wire feeder I have seen this, but mine is insulated copper wire. This water changes the dielectric constant, which shifts the velocity factor and the impedance. You will often have to retune your antenna when it rains. Requires a tuner or balun. Modern transceivers have 50 ohm unbalanced outputs. To use ladder line, you must use a balanced antenna tuner or a standard tuner coupled with a 1:1 or 4:1 current balun to transition from the balanced line to the unbalanced radio. I am using both 4:1 current balun as well as 1:1 common mode choke.